Hi, everyone. My name is James Chen. I'm a distinguished professor from Department of Power Mechanical Engineering, National Tsinghua University, Taiwan. Today is my honor to take this chance to introduce you our recent work on the robot. The title of the presentation is Dual-Arm Humanoid Robot with Intelligent Perception for Dexterous Grasping. Well, the motivation of this work actually is motivated by the aging population we have observed worldwide. So you can see that the world actually has become older and older in terms of our human race. By 2025, there's a 15% of the population will reach over 60 years old. And by 2050, over 25% of people around the world are over 60 years old. So you can see that this is becoming a problem globally, but only in Taiwan or in Asia. However, in Taiwan, the problem has become severe. Why is that? Because Taiwan is reaching the super age population by 2025. The definition of super age population is that over 21% of the population should be over 65 years old. So you can see on this page here, 4 years later, Taiwan actually has become a super age society. And while reaching the super age society, they've come with a problem. Despite of the increase in medical expenses, the society also encountered problems such as the lacking of labor force in the factory, and also the raising or increasing demand for elderly care. And there's many possible solutions to kind of overcome the aging population. However, one of the solutions we propose is that to use the humanoid robot to surrogate the labor force. You can see that right now in the factory, we use a human as an operator. However, because the society has become very old in 4 years later for Taiwan, it is possible to use the robot to kind of replace the human force in the factory. So you can see here with the introduction of the human-like robot in the labor market, and then we can kind of replace this shortage of labor in the economic domain. Not only the factory or industry is facing the shortage of labor, but also the recent increase and a certain increase of the COVID-19 worldwide. And there's a lot of demands of using the robot to replace humans, especially in the hospital environment. Why is that? Because one COVID-19 carrier can infect 5 people, and medical protection is very important nowadays. And you can see that we use the robot to replace the tedious labor work in the hospital environment, and we can prevent the spread of the infectious virus to our society. Well, here's kind of the breakdown of the special feature of our human-like robot. First of all, the robot, just like a human, just you can see here, we kind of designed the robot like a Star Wars trooper, just for fun, but the size of the robot is more like me, and so the weight is about 80 kilograms. And the robot has a vision system with a human-like head. You can move 360 degrees. And also you have a robotic arm, kind of different from the traditional 6 degrees of freedom robotic arm. We have a 7 degrees of freedom or 7-axis robotic arm that can reach anywhere and with a different orientation for the robotic arm or grasping the object. And about the hand, the hand of the robotic arm, the robot we designed, is kind of like a human, kind of quite different from the traditional robotic design, which is like the grippers are like open and closed, just like a chopstick. But our robot just equipped with the grasping device like a human hand. So 5-finger the robotic hand with a soft robotic actuator, and also the adaptive design in the structure. First of all, I'd like to kind of introduce you the robot intelligence vision system. So as you can see here, the robot can move his head freely, and at the same time, it can capture the image. The image is not only 2D, but also 3D. That means I can measure the distance between the object and robot, and also can, with the AI algorithm embedded in the computer inside the robot, we can track different objects and recognize even the human skeleton, as you can see here, in real time. And the robot can check multiple objects, and I think it is quite interesting because the robot can replace a human work, but however, it can perform better than human. For example, the robot can check multiple objects at the same time, so the application can be used in the security area and also in the so-called like hospital area to kind of distinguish different testament from the patient. And our robot, we have a human-like 7-axis dexterous arm. Why this is so interesting? Most of the time, our traditional robot is a 6 degrees of freedom design. And with a 7 degrees of freedom, just like you can host, like fix this point. However, your arm actually can have different orientation. With a traditional 6 degrees of freedom design, it can only have one orientation. With this kind of 7-axis degree or 7 degrees of freedom design, we can kind of mimic the human motion into the application. And to be able to kind of teach the robot to perform human motion, we have this US patented technology we call IMU, and in which we can kind of measure the angle and orientation at the same time for different objects and different linkage. You can see that we have this data graph and then have a sensory array. We can measure this any post and any orientation of the human hand. So the application for that is that we can digitize the human motion and transfer to the AI system and train it, and so it can evolve different technology, even knowledge, and also can preserve the experienced workers' hand motion, for example. And for the medical application, you can also teach the robot by the medical personnel and to kind of perform some sort of dexterous work and then in the hospital environment. In our robot, we also have a sub-actuators. Safety is the first priority. And for the sub-actuator in the robotic hand, we can just like you can shake hand with the robot hand and just like a human. And also inside the robotic hand, we have a sensor to measure this kind of motion and also perform this open and close motion, just like a human. And with the adaptive design in our structure, we can use one motor to pull the tendon to move the finger of the robot hand and to grasp any object. So traditionally, you only have that open and close, but right now, our robotic hand can grasp any object like a human. And while grasping a different object, the robot hand also equipped with a sensor inside. So basically, we can grasp object with a feeling. So this sensor is using magnetic sensors, and it can measure the force in 3 dimensions at the same time. So basically, we can use this kind of technology to kind of know the weight of the glass you are going to hold, and while putting the water inside the glass. And as I was talking about, safety is the first priority. And our robot has an embedded AI system, and it can check different objects, and at the same time can have this kind of automatically a very smart non-contact obstacle avoidance technology to prevent the contact between the human and the robot. So as I was talking about, there's lots of different features and new features in our human-like robot. And with this human-like robot, I believe there's an endless possibility of application. For example, can be used in daily life, can be used in the factory, can be used in security or military, and also can be used in the hospital environment to prevent the spread of COVID-19. Well, thank you very much for listening. I hope you enjoy my presentation. Should you have any comment or any needs for further discussion, you can reach me by the following the email in the bottom of the slides. Thank you very much.